check the system again. If I have it, yes. If not, Christopher, did you miss the class last time?
Yeah, I did. And then I was trying to see the video and I couldn't find it for the.
Okay, Christopher, if I don't have the lecture video, Wednesday, if you have time, come online at 8:30 in my office hour. I'll explain the lecture again to you. Is it working?
Okay. Thank you. Thank you very much.
Okay, let's start 4.7. You see it, I jumped. I explained to you 4.5. Now I'm jumping to 4.7. Why not 4.6? Because 4.6, you have to use calculator for that one. It's graphing in TI-84 or TI-84 plus. We are not using TI in the class. And that's why I'm not going to explain how to graph a function in TI. Even you can do it by yourself. It's really easy. 4.7, we are discussing today optimization problems. What does it mean? Optimization problems means maximizing or minimizing a continuous function. You see, even you don't have this topic in your book, but I put it in blue for you here, that maximization means, optimization means maximizing a function, a continuous function, or minimizing a continuous function. What does it mean in the real life? Today, what I'm dealing here, I'm dealing with all word problems, applications. For example, in our daily life, sometimes, let's say you are working with a company that its product is, for example, food, or they have clothing products, something like that. Your boss is asking you for a special product, how to minimize the cost of the product, or how to maximize the profit. Or you're an engineer and you are working on a pipeline, how to minimize the cost of that pipeline. Or in simple, you want to make a box at home, correct? A rectangular box. How to find by a certain area that's given to you, for example, let's say 30 by 20 inches, how you can make a box with the maximum space in it, correct? Or maximum value. These kind of problems, we call it optimization. And it's really easy if you know 4.3 and 4.4. It's really, really easy. They are word problems, but they are easy. Anyway, we will talk about two types of the continuous functions here. First, a continuous function and closed interval. When I'm talking about closed interval, it means I'll start from, for example, A and I'm going to B. And if even you want to see the graph, a closed interval, for example, if I draw a function, will be something like this, right? For example, this is point A, this is point B. I'm studying here, working on a closed interval, which is not continue to infinity, this side or this side, it's closed. And also we will discuss open intervals, a continuous function and open interval. When I'm talking about open interval, I'm not using bracket here, I'm using parentheses. That means I don't have these closed circles here, correct? The function is continuous and I don't know to the end. When we talk about optimization, when we talk about maximizing or minimizing a function in a closed interval, you see, if you see this graph, this function definitely has an absolute max or an absolute min, because I'm dealing with a closed interval, correct? These points, you can, when you are dealing with, if you remember, I explained to you, when your interval is closed, you have an absolute max and you have also an, or maybe an absolute min. When you are dealing with open interval, you may have an absolute max or may not, correct? Because it's open. Now, when you are dealing with optimization problems here, you have an answer. Definitely you have an answer when you are dealing with closed interval. When you are dealing with open interval, you may have an answer or you may not. Explaining these problems this way is not working for you. I will start with examples, with very easy examples, and I'll explain to you what does it mean minimization or maximization of a function. For example, let's consider this example. If I ask you, fence a rectangular region or field, rectangular field or region, correct? And maximize the area. Correct? And if I give you only like around 100 feet of fence, you have only 100 feet of fence. I'm asking you to fence a rectangular shape using this 100 feet, but fence it the way that you can cover the maximum area, you can cover the maximum fence. Because of COVID-19, all of us, we are at home. Even I see my neighbors, everyone is working at the backyard, everyone is doing something. It's a lot of projects going on around us. Maybe you want to fence your garden, correct? And you have some fence at home. How to cover that area, the maximum area with that amount of fence that you have. Usually when you are dealing with maximizing or minimizing problems, you have to create a formula. To create a formula, you need to draw a diagram, correct? Okay, my field that they are asking me is a rectangular shape. I will draw a rectangle like this. I can name this side Y. I can name this side X, correct? In a rectangle. If this is X, what is this side? This side is definitely also how much? X. If this is Y, here you have also Y. Now, you need few things. You need a formula. And also we call it constraint. What is your constraint? What you can do? Your constraint is actually here 100 feet. That's your constraint, correct? What you want to maximize, you have to evaluate the problem. What I want to maximize, I want to maximize the area. The area of what? The area of a rectangle. Then your formula is A equals, what is the area formula for a rectangle? The easiest area formula. What is the area for a rectangle? It's X times Y, right? If you multiply with X, Y with X, it gives you the area. Now, I have 100 feet. 100 feet, if you use, you can fence around, correct? It means you are dealing with parameter. What is the parameter formula in this special case for this rectangle? How many X's I have? I have two sides, which is X. It means I can write 2X. I have two sides, that they are y, I can write 2y. In total, how much fence I have to use, it's given to me. It's 100 feet. You see, you created another formula here. Usually what we do, we solve, or let me say this way for you, solve the constraint for a variable, and substitute into formula. Here, I have 2x plus 2y equals 100. Look, my formula is a equal xy. I have two variables, right? And I have to deal with derivatives. Can I take the derivatives of a function in two variables? Yes, using implicit derivative, but it's not going to help me. It's much better to have this formula in one variable. What I will do, I will solve this function, the constraint function, for y. To solve for y, you have to subtract 2x from both sides first, right? It means 2y equals 100 minus 2x. Now divide everything by 2. Y equals 50 minus x. Use the constraint equation for one variable and substitute this value in the formula. You see, I'm drawing an arrow for you, even I show what I will do. I will substitute the value of y in my formula. Then my formula becomes like this. A equals x times 50 minus x. Correct? If you remember 4.3, if I have a function like this, let's say like this, a continuous function in a closed interval. This is the max point, right? This is your maximum point. What was the process to find the max or min in 4.3? What should you do with your function to find the max or minimum point? Who can answer? What should I do? Any idea?
Find the first derivative first.
Excellent, excellent. You have to look for the first derivative. What is your first derivative? What does it mean? What is first derivative? What is first derivative? In calculus,
F
when
prime
you
of
take
x.
derivative, what does it mean? The slope of?
The rate of change.
The rate of change, the slope, or the easy language, the slope of tangent line, right? You see in your maximum point, the slope of tangent line is 0, right? Because you have a horizontal line. It means in maximization or in general in optimization problem, you always use the first derivative after you create your function. Use your first derivative, find the first derivative of the function, make it equal to 0, and after that find the critical numbers, and you see in which number you have the maximum, correct? That's it, that's that simple. Okay, now here I have to find a prime. That means I have to find dA over dx, right? Where a prime is dA over dx. To find dA over dx, even before that, it's a good idea. You can use the product rule, or you can distribute the x or make it easier, right? Which gives you 50x minus x squared. Now, take the derivative of this function, which is 50x minus x squared. What is the derivative of 50x minus x squared? The first derivative of 50x minus x squared. It gives you 50 minus what? 2x. Understand what I did? I find a prime. Now, I have to set a prime. It means I have to set dA over dx equal to 0. It means 50 minus 2x equals 0. Solve it for x. Solve it for x. From here, if I solve for x, I have to subtract 50 first from both sides, right? Then negative 2x equals negative 50. It means x equal 25. Am I right? What is x? X is actually this side in your rectangle, correct? X can be 25. It means 25, 25, 25, 25. But it's not the only option. I have 100 feet. I can use like 50 feet on this side. I can use 50 feet on this side also. I'm sorry. I'm sorry. 50 feet on this side, 50 feet on this side, right? But you see, if I use 50 feet on this side, if I use 50 feet on this side, 50 feet on this side, there is no fence to use for y. It means I'll end up with these two lines. 50 feet one side, 50 feet on the other side. Do I have an area inside in this case? Can I find an area? How much is my area? How much is the area if I use 50-50 on these two sides? Y will be 0, right? Y will be 0, Y will be 0. How much will be my area? 0, right? Or I can use for x 0. 0 feet this side, 0 feet this side, 50 here, 50 here. It means my x can be 25, my x can be 0, or my x maximum can be 50. I have these three options to use the fence, correct? 0 and 50 are actually for us, these are the end points, correct? These are the end points of your function because at total you have 100. X can be greater equal to 0 or less than equal 50. 50 and 0 are the end points. 25 is a local max or local min. It's a critical point, right? 25 is your critical point. 0 and 50 is the end points. Now you learned in 4.3 that if you plug this number, your critical point, or if you plug your endpoints to the given function, you can see which point of these is your maximum point, right? If 25 is maximum, if 0 is maximum, or 50. I know I explained to you that x equals 0 or x equals 50, you will not get a maximum area. I show it in the picture for you, but look at your function. Your function is a equals x times 50 minus x, right? That was the function? Yeah, 50 minus x. Look, if I plug in 0 here, when x is 0, this one, my area will be a equals 0 times 50 minus 0, which my area becomes 0. If I use the other endpoint, which is 50, I have a equals x times 50 minus x. When x is 50, if I plug in 50 in this equation, then a will be equal 50 times 50 minus 50, which gives you 0. 0 times 50 is 0. My area is not maximized. My area is not maximized. What about x equal 25? Again, I have a equals x times x, 50 minus x. If I use this critical point, which is 25, and I plug in here, let's see how much area we get. A equals 25 times 50 minus 25, which gives you A equals 25 times 25, which gives you what? 625, am I right? 25 times 25. Your total area will be 625. You see, if you do a check like this, analyze like this, when x was equal 0, your area was 0. When x equals 25, your area is 625. And when your x was 50, the other endpoint, your area was 0. Which one is the maximum? 625. Correct? Now you can say, if I use x equal 25 feet for x, I can get a maximum area of 25 with 100 feet of fence. Okay, when x is 25, how much is y? Maybe you ask me, okay, how much is y? You have this formula, 2x plus 2y equals 100, right? If you plug in here the value of x, 2 times 25 plus 2y equals 100. And easily you can find the value of y. 15 plus 2y equals 100. It means 2y equals 50. It means y equals 25. It means actually your shape becomes a kind of square shape. Here 25, here 25, here 25, here 25. If you use 25, 25, 25, you can fence the maximum area of 625 feet with 100 feet of fence, correct? We call these kind of problems maximization or optimization problems, correct? I'll do more examples for you, maybe one or two more. Any question on this example? Please do not write your question again in the chat. I cannot see the chat. Ask me directly, like face to face.
So what we're doing here is we're maximizing the area of the fence itself.
The area of our field.
Oh.
If I have 100 feet of fence with using only 100 feet, how can I fence a rectangular shape that gives me a maximum area, right? Not wasting the fence. That will be 625 feet or square feet, correct? But how your all sides should be 25, correct?
Oh, okay.
And second example, it will be more clear for you. Look, second example.
So what we just did right there, what we just did right there, that was just checking. It was like a proof, like checking the work that we did.
Not a proof, actually. I find that how much should be X, how much should be Y to get the maximum area, correct? Okay. Even you found how much is your maximum area. You are working for a kind of fencing company, right?
Yeah.
Someone tells you, oh, I have 600 feet of fence. I want to fence my garden. I have only this much money, 600. Use my fence to cover or give me the maximum area of fencing, right?
Yeah.
That's how you use this.
All right.
Look at this example. For example, you are working for FedEx or another or a storage company. Your boss gives you something like this. A cardboard, and your boss is asking you to make a box that have a maximum value in it, correct? The sides are given like this to you. It's 30 inches from here to here. It's 16 inches from here to here. And you have to cut by X amount to can make a box, right? Because if you do a cut, if you cut this area, if you cut this area, if you cut this area, and if you cut this area, you will end up with a box something like this. Let me draw, if I can draw a good box for you. I'm trying. If I use pen, I can draw very nice, but here with this pen, it's really difficult. I cannot control my hand. Oh, something like a box, right? They're asking you to make a box like this. But which type of the box? You have only this cardboard and this size, right? How much should be the height of the box? How much should be the width of the box? How much should be the length of the box actually to get the maximum value? You are working for a company. Your boss says, I have a lot of these cardboards, 1,000, 2,000, 10,000 of them in my storage. I don't want to throw it away. Make boxes out of that to have the maximum capacity or maximum value. Correct? You have to design, you have to calculate. Now, few questions for you. If from here to here is 30, how much is the total length from here to here? How much is the total? Or I can say, if I show it to you here in this picture, how much is this total length? From here to here is 30, here is X, here is X. How much is total?
$30 plus 2x.
30 plus 2x. It means if I write here, this drawing is not good. The total is 30. The boss gives you a total cardboard, not partial of it, right? Let me clean it a little bit. I did 2 steps faster than I should show it to you. This total is 16. And this total is 30. It means you have a cardboard 16 by 30. How much you should do a cut, how much each cut should be to get the maximum value. Now, if the total is 30, this is small portion after the cut will be 30 minus 2x, right? It means this length will be 30 minus 2x. And this length will be 16 minus 2x. How much is the height? The height will be this x, right? Now, your formula. What you are looking after, volume or area? What we are looking after, maximum volume or maximum area? In a box, you are looking for a maximum area or volume in a box?
Volume.
Volume, right? What is the formula for the volume of a rectangular shape? Length times width times height, right? In this particular example, it will be x times 16 minus 2x times 30 minus 2x. Understand this part, how I put everything together to create a formula? Now, what is next step? When I have the formula, what should I do? Find the first derivative of this function, right? It means find the slope of the tangent line. It means find the v prime. But before the v prime, please do not use the product rule here because it will create a lot of problem for you. Try to distribute and make it a simple function for you, right? First distribute x here. V equals 16x minus 2x squared times 30 minus 2x. Even I'll tell you to FOIL it. It makes it more easier and you will end up with 4x cubed minus 92x squared plus 480x. Check for me if you file, do you end up with this function? Take a minute and check it. Because I did this problem early morning, I was kind of sleepy. Maybe I had a mistake. Check it for me, please. Am I right with these values? After distribution, after foiling, right? Now find the v prime. What is v prime? Take the derivative of this side. It will be 12x squared minus 92 times 2. 184 x plus 480. Am I right? Next step, finding critical number. It means v prime equals 0. It means 12x squared minus 184x plus 480 equals 0. I think we can divide by 4. Let's divide everything first by 4, make it smaller, correct? If you divide by 4, everything like this, make it smaller because it's too big. It gives you 3x squared minus 46x plus 120 equals 0. Can we factor? Maybe yes, maybe no. It's big numbers. Even I don't know, can we factor or not? How you find the critical values if you cannot factor? What is the next way to find the critical numbers? Algebra, please. I cannot factor this quadratic equation. What can I do to solve it? Solving quadratic equation, another method, not factoring. What's the formula? Quadratic formula. Do you have a tattoo of quadratic formula in your body? I had a student that had that formula as a tattoo. Correct? If you are a science major, have a tattoo of pi like me, or maybe a formula, something like that, right? No, I'm just kidding. I'm not encouraging you, right? Let's use the quadratic formula. Quadratic formula, please. X equals
plus or minus
negative b plus minus square root of b squared minus 4ac over what? 2a. I don't know the spelling of my name, but I know this formula, every piece of it, right? Let's plug in the values, please, and give me an answer. Negative b, it means 46, plus minus a square root of 46 square minus 4 times A, 3 times C, 120. All over 2 times 3, which gives you 46 plus minus square root of, can you simplify under the square root and tell me how much is that? If my number is correct. If you have a calculator, please use it and simplify and see if my number is correct. I got 676. What is the square root of 676?
$26.
26 over what? 6. From here, you end up with two values of x, right? One of them will be x equals 46 plus 26 over 6, which gives you what? 72 over 6, am I right? Yeah, 72 over 6, which gives you how much? What is 72 over 6? 12? And the other one, x equals 46 minus 26 over 6, which gives you what? 20 over 6, which means 10 over 3. Okay, now a question for you. Look at the box. Look at your cardboard. This side was 16. This side was 30. X is actually this cat, right? X shows how much you should cut from the sides. That was your X, right? X shows the cat for you. Can I use X12 for my cat? Look at the picture. Can I use 12 for this cat? Can X be 12? What is 12 plus 12? 24, even you have 16. You cannot use X equal 12, right? Because it's more than the width of the cardboard, right? Then you have one critical point, which is 10 over 3, correct? Now, one of your critical point is, or critical number is 10 over 3. You have a number bigger than this, you have a number less than this. Look at the width is 16. X can be less than equal these two numbers. One of them is definitely 0. You don't cut, take the piece of the cardboard back to your boss and say, okay, I made a box. He will kick you out from the office in a minute. Say, go away, I don't need you. I asked you to make a box, right? Even you didn't cut, even you didn't make a box. If X is 0, right? It means do not do any cut. What will be the highest value of X can take? How much this X can be, the highest? If total is 16, how much will be the highest X can you take? Come on, guys, it's early morning. Think you had your coffee with you? How much? How much X can take? If it's 16, what will be the highest? What is half of 16?
8.
The highest will be 8. But if you do a cut of 8, again, your boss will kick you out, especially if I'm your boss, right? Because you will give him 4 pieces of cardboard and say, sir, this is your box. Say, go home, right? Do not come back to the office. That's the maximum. It means here you have X equal 8, here you have X equal 0. These are actually your endpoints. 10 over 3 is kind of local max or local min. It's your critical point. Now, to understand what is the maximum value, you have to plug in all these three numbers where and which function, and v prime or in v, to find the maximum value. Which function you are using, v or v prime? V, right? Because if you plug in these numbers in v prime, it gives you 0. You have to plug it in v, and your v was x times something, or maybe the big one that we already multiplied, the last one. V was equal 12, 4x cubed minus any of them that you want to use. What was that? 4x cubed minus 92 x squared plus 480x. Go ahead, please plug in 8, 10 over 3, and 0, and gives me some values. Do you want to do that? If you have a calculator, it's easy. If you don't have a calculator, it's kind of difficult to calculate with your hand. Just check my numbers. I calculated for you. When x is 8, your volume becomes 0. When x is 0, definitely the volume is 0. Because here I think you have another x also. Your 480x, right? You have another, this one becomes 0. And if you plug in 10 over 3, do you end up with 726? Yes? I think that's the right number, correct? What does it mean? You can have the maximum value if your cut is like what? If your cut is here 10 over 3, which is 3 1/3, right? Here 10 over 3. Same thing on this side, same thing on this side, same thing on this side. If you do a cut like this, you will get a box with the maximum value of 726 cubic inch. Interesting? I know some of you complain that this teacher is not teaching word problems at all, right? Today I give you some word problems. If I pick a word problem, I pick the difficult one. They are not difficult, to be honest. They are easy. These two problems that I did for you, they were all about maximization. Correct? Let's do a problem on minimizing. The idea is the same. Minimizing your function, the minimum in your function, correct? Still, you have to find the tangent for that line. Still, you have to take the first derivative. The process is the same, correct? I found another interesting problem for you for this one. Let's say some of you become engineer, correct? You are working in a company that builds pipelines, oil pipelines or water pipelines, correct? For example, here you have the C, it's C. Inside the C, you have the oil. B is the point, I will call it a stopping point, or your station. You want to bring the oil from the sea through a pipeline. You have to build a pipeline. You want to transport the oil to point B. Let's say, and it's real in real life, if you, for example, connect a pipe under the sea from this point to here, it always costs you more, right? Because you do the pipeline under the sea. It's not that easy. That job is not easy. It's really cost a lot. But in this problem, I use simple numbers. For example, the cost will be $1 per kilometer. Sorry, I used kilometer, the standard notation, metric one. I know it's difficult in US, but still we do kilometer in US. And the ocean. If they cost you $1 in the ocean per kilometer, let's say the cost will be half of the price per kilometer inland. Now, your boss is coming to you. He's a greedy man like some of us. He's running a big construction company, because when you're a big businessman, you become more greedy and greedy and greedy. He's asking you, please, please, please calculate something, a project for me that cost me minimum. The cost should be minimum for me. The cost of construction, correct? You cannot say, no, sir, I cannot do it. You are an engineer, you have to do it, right? Make your boss happy to pay you. For example, the total distance from A to B, this distance, let's say from A to B, it's 8 kilometers. And the distance from the sea to this point of the land is 5 kilometers. Now, you can follow this picture. You can do some pipeline from the sea to this point. Then connect this point to B. Maybe it costs you less. Or, I don't know, maybe if you do all of them under the sea, maybe it costs you less. Or maybe there is another point also. Look, it's not only two options. Do I have a third, fourth, fifth, sixth, many other options also? What do you think? Look at the picture. How do you connect these points? Do you have more options? Can I do this? If I come first here to this point, let's name it P. Then from here to B. Can I do that? Maybe. Maybe it costs me less. Or maybe if I move P here, move P here, P can move to any point, right? This is how I start my problem here, correct? To find the minimum cost. Okay, now, few questions for you. I will redraw the diagram here to ask you a few questions. Point B, point A, here P. Let's name, the total was from here to here, from point A to B, 8 kilometers, right? If this portion, if I name it X from A to P, how much is this portion? From P to P. An engineer in the class? If this is X from A to P, how much is from P to B? The total is 8 kilometers. How much will be this portion? If from A to P is 2 kilometers, how much is from P to B? Come on, guys. Total, you have 8 kilometers.
That'd be
If from
six.
A to B is 2, how much is from P to B?
6.
6. How do you find 6?
So
8 minus 2, right? If this is X, this portion will be 8 minus X. Right? Okay. Now it's time to create a formula. What we are looking after, we want to minimize the cost, right? Definitely, you need to connect your oil from the sea to the ground first. Any point, I don't know. You need to use some cost under the sea, right? You have to do some job there. Definitely, you cannot avoid that, right? It means your total cost, if I show it with the sea, your total cost equals the cost of pipe at sea plus the cost of pipe in land, right? That's my formula. In this particular example, how much land work I have in this diagram, how much land work I will do from P to where? To B. The pipe goes in the land from P to B. How much is that? 8 minus X. That distance is 8 minus X. Every kilometer it costs how much in the land? 1/2, right? 1/2 of dollar, half a dollar. That's this cost of the pipe on the land. Now, I want to connect this way. If this is X, and if this is 5 kilometers, how much is this side? I can write recommendation letter to send you back to trigonometry class. If this is X, this is 5, how much is this side? The square root of? In a right triangle,
20.
this side equals the square root of the legs, right? It means x squared plus 25, right? This side, it means this distance will be x square root of x squared 25. That is the pipe at sea. Okay, now let's create our formula. My cost equals pipe at sea, which was square root of x squared plus 25. How much is the cost of the pipe at sea? $1. Plus the cost of the pipe on land, 1/2 of 8 minus x. That is your formula that you have to do. We don't care about this dollar sign, right? Can you find for me C prime, please? Go ahead, give me. Today is test day. Find C prime for me, please. The first derivative. Anyone? C prime?
Yeah.
Yes, sir.
2x
Uh-huh.
over x squared plus 25 to the power of 1/2. And
X
then-
squared 25 to the power of 1/2.
Yeah.
Square
2x.
root of x squared plus 25 to the power of 1/2, like this.
No, just the square root.
Square root of, can you read it again?
Yeah, 2x over the square root of x squared plus 25. Stop.
Full stop, that's it.
And then minus 1/2.
Minus 1/2. Did you miss a 2 somewhere?
Oh, yeah, there's a 2 in the denominator.
It means you don't have a 2 here, right?
Yeah.
That's a correct derivative. Let's find it. I'll help you. The first part of this function C, you see, you have to use the chain rule, right? The derivative of outside 1/2 times x squared plus 25 to the power of, subtract 1 from 1/2 gives you negative 1/2, times the derivative of inside, which is 2x, plus what is the derivative of 4? 0. And what is the derivative of 1/2 x? Gives you 1/2. Correct? Simplify. C prime equals. Send the negative exponent to denominator. You can write, even you can cancel this 2 with this 2. You can write x over square root of x squared plus 25 minus 1/2. This is my first derivative, right? Now, what is next step? To find max or min, what will you do? To find critical point, what is next step? C prime what? Equal to 0. It means x over x squared plus 25 minus 1/2 equals 0. Ideas, how to deal with this equation? Give me a good idea.
Common denominator.
Yeah, I don't like it that much. Yes, you can do that. Do you want to create more problems for you? Do it. Another easy way. Can I move the constant to the right side? The 1/2?
Yes.
Let's move this one to this side. Then x over square root of x squared plus 25 equals 1/2. What is this equation? What we call this type of equation? A fraction equal another fraction. We call it what? You want to go back to grade 5 school?
Cross multiply.
Cross multiply. You can do cross multiply on which kind of equation? What we call? Give me a name. A fraction equal fraction.
A proportion.
Proportion. Excellent, right? It's a proportion. It means you can do cross multiply, correct? It means you can write 2 times x equals 1 times square root of x squared plus 25. Do you remember your intermediate algebra, college algebra? It's an equation involving what? Radical. How to solve? Raise both sides to which power?
Square root.
The power of index, right? Whatever the index is. It means here square it. 2x all squared equals a square root of x squared plus 25 all squared. It gives you 4x squared equals, here cancels out the square root with that square, you end up with x squared plus 25. Move the x squared to the other side, subtract x squared from both sides. It gives you 3x squared equals 25. What is next step? Square root or divide? Which one comes first? Should I take the square root immediately or divide?
Divide first.
Divide first. Excellent. Why I ask this question? Because it's a common mistake between the students. They take immediately the square root. No, first divide. You have to have x squared alone. X squared equals 25 over 3. Now take the square root from both sides. Square root of x squared equals, what should I use on the right side? What I missed to write here?
Plus or minus.
Excellent. Plus minus, it's really important. X equals, the square root of 25 is 5 plus minus 5 over a square root of 3, or if you rationalize, x equals plus minus 5 radical 3 over 3. Am I right? If you rationalize. Now, which answer is incorrect here?
The negative?
Why? Correct. Excellent. Why? Give me a reason. Why negative? Because distance
because-
cannot be negative.
Because we're running a pipeline, we can't run a negative distance.
Yeah, that's the reason. Even if you use negative, it means you are going this way. Instead of coming to the point B, you have to go this way, right? More far. That's why we are not calculating the negative point. The only critical point here will be 5 radical 3 over 3. That's a critical point. Now, you need the endpoints also. What are your endpoints? The total kilometer was 8, and on the other side, it can be 0, right? These are your endpoints. Now you have to check. When x equals 0, how much is the cost? When x is equal 5 radical 3 over 3, how much is the cost? And when x is equal 8, how much is the cost? You have to calculate all these costs for me. It means plug in this number back to the cost function. Plug in 0 in the cost function gives you what? Calculate, please. I think it's $9 something. Plug in 0 in this function, in your cost function. That's your cost function here. This one is your cost function. The function that you start working with. Plug in 0 here. Square root of 25 is 5, and here 8 minus 0 is 8, and 1/2 of 8 is 4. 4 plus 5 is 9, right? When it's 8, I think you will end up with 9.4 something for $3. Please calculate for me. And when it's 5 radical 3 over 3, that will be $8.33. Which one is the minimum cost?
Yeah.
This one, right? This one is your minimum cost. $8.33. It means how you should move, how you should connect your pipeline. You should come this way, then from here to here. That costs you minimum, not a straight like this, not a straight like this. Because I used like $1, you know, $1 is not real. A cost of pipeline under the sea, $1, it's not even close to real. It's millions, billions of cost, right? Millions of dollars, billions of dollars. You may tell me that, look, it's not that the big difference between 9 and 8.3 or between 9.43 and 833, but think about billions. Think about a real distance, not 8 kilometers. It will be, you can save millions and millions of dollars, or you can lose. The only thing that I didn't calculate, you may tell me in a real life, oh, we have to buy this land. Yes, you may. In some cases, there are houses, you have to pay the people to go away and buy those land to connect. Yes, in real life, we calculate everything. But at least I calculated here to show you how you can find the minimum cost, correct? If you go to business calculus class, they teach you this stuff, more on the cost stuff, not in my class. I cover physics, everything, but in business calculus, you will deal with these kind of functions a lot, correct? This was all topics about optimization, and I hope that I could explain it well today for you to get an idea of what is optimization. Optimization means create your function, take the first derivative. Can I do the second derivative also? If I do second derivative, can I find my max and min through second derivative also? Who wanna answer? I just use first derivative. Can I do through second derivative also? Concave up, concave down, sign change, right? Even you can find that way also, but the easy way is using the first derivative, correct? Use the first derivative, set it equal to 0, that's it. The main problem is how to create your formula. You have to think how to create the formula. Then first derivative, set it equals 0, critical points, endpoints, plug in back to function. It gives you the maximization or minimization, the maximum or minimum point of your function. Question now. Yes, no? Okay. If you don't have a question, I'll stop recording here. And I'll start working on your study guide 3. Soon you will receive, because I have only one more topic to discuss, which is the Newton's formula or Newton's method. I will talk a little bit about Newton's method. I had planned to skip it, but it's really interesting. We have time. Let's focus on that, or maybe not, maybe jump to antiderivatives, which is the last topic of this chapter. It means I'll give you ideas of integrals, not by name of integral, by name of antiderivative. But your next chapter, I will talk about differential calculus, which we call it integrals, correct? Up to now, you did calculus with derivatives. Next chapter, we are doing calculus with integrals. It means we are looking for the areas under the curve. And that's also interesting, correct? But before that, of course, a test. If you don't have a question now for me, I'll end the meeting and I'll see you all at 9 Wednesday. But if you have a question, you can use my office hour. You can come online at 8:30, correct?